Hey everyone, this is Daniel coming up with another long form conversation. And today my guest is José Valim. He's a software engineer and the creator of the Elixir language, which I find fascinating. José is focused on developing and growing the Elixir language and the ecosystem at his company Dashbit, which also made Tidewave, a full stack coding agent in the browser, and Livebook, which is a Jupyter-style notebook for the Elixir language. Before Elixir, José was a core Ruby contributor, and he co-founded Plataformatec, a company which was acquired by Nubank, a Brazilian bank which also happens to be a big functional programming shop. And this conversation is very wide-ranging. We cover a lot of technical things, including type systems. We spend quite a bunch of time talking about Elixir's new type inference and comparing type systems of various kinds. And we also talk about the Erlang virtual machine, the Beam, compared that to the JVM. We talk about fault tolerance, distributed systems, error handling, and all the good stuff. We talk about AI and how Elixir positions itself for this day and age. And we also talk about slightly less technical things, about open source, about leadership, about coaching, and enabling other developers to do their best work. I had a fascinating conversation, and I hope you'll find it just as fun as I did. So without further ado, please welcome José Valim. José, it's good to finally meet. Thank you so much for making the time.
Thanks for having me.
So I think this conversation is probably going to land on good time because you are releasing candidates for Elixir 120, which aims to add type inference on all constructs. I hope I'm getting the quote right. What does that mean, and how is that going to work for a language that was originally intended to be dynamically typed?
Right. So yeah, so it may be a long answer. So to give everybody a little bit of a background, about 3 or 4 years ago, I think it has been 4 years since we started. We started to research a type system for Elixir, and Elixir is a dynamic programming language that runs on the Erlang virtual machine. And this is not like my first attempt at type systems. About like 2017, 2018, I actually tried to implement it I tried to implement a type system for Elixir using intersection types. I built some prototypes, and then the prototypes, they were like very slow. And I went to talk. I was like, oh, I went to talk to. That's kind of sad. And then I went to talk to some people in academia, and everybody was like, "Oh yeah, we know like intersection types in lambda calculus. They are known to be slow," which is kind of funny because like none of the papers mentioned that, but it was known, right? But the papers, because the papers are not, they're interested in making it possible, not necessarily if it's going to be fast or not. And then some time passed. Two students from Uruguay, they did their masters in adding a gradual type system for Elixir. I reached out to them like, hey, maybe you want to work on it. And they were like, nope, we are out of university, never coming back. When I looked at the citations in that paper, most of the citations was pointing to work from Giuseppe Castagna, which is a very known researcher on type systems, and in particular, set-theoretic types. So it's a different approach to type systems, and it's not like your usual Hindley-Milner type system, and it has set operations as its basic operations where you do everything. And it also, in this particular case, it also has a property that we call semantic subtyping, in where the subtype itself is represented as set operations, right? So you check, hey, is this set contained in this other set? So it was very interesting. We started talking. I started to understand the approach. One of the things that I immediately liked, because everything was based in set theory, it feels like in some ways like quite simple, because that's something that you learn like very early on, right?
In
I don't know,
math.
maybe fifth grade. Yeah, right. So it's about unions, intersections, um, containment, and so on. And I reached out to Giuseppe Castanha, which I'll probably refer during in the middle of this episode as Beppe, because that's how I call him. So if I say Beppe, it's Giuseppe Castanha. And when we started talking, he already had a student in mind, which is Guillaume Duboc, to do a PhD thesis on like bringing a type system to Elixir. And one of the things that, so that's kind of how it started. And and now going like to the other part of the question, like how is that potentially looking like, right? So one of the big challenges is that Elixir is an existing programming language, right? So we need, so and all type systems they restrict the amount of code you can write, right? They're not complete. So sometimes you're going to write code and you're like, look, this code makes total sense to me, but the type system's like, nah, I can't prove this is correct. So this code is not valid. You have to rewrite it, right? So when you have an existing language, that obviously causes some tension because if we add a type system and now we can type a huge amount of Elixir projects, that's going to definitely not be a good user experience, right? So when this PhD work started, the idea was, well, we have this existing set-theoretic types, we have theory, and we have this existing language. How much of Elixir can we type with the theory that we have today? And in the places where we're like, oh, we don't have enough theory, can we develop new theory? And that's actually what has happened in the last 3 to 4 years. We have been like developing new theory, publishing papers, um, to solve exactly this gap. And every release for the last four releases, like starting from Elixir 1.17, we were slowly adding a little bit of like type information to the compiler. So for these constructs, we started type checking them, then we started type checking function calls, we started type checking some data structures. And when we did not type check a particular part of the program, we would just say, okay, we don't know anything about this program. We could just ignore that particular chunk. And the idea behind this process was is that we would slowly add type to the compiler, and the compiler will start type checking your program, but without you adding type signatures. So we would only look at your program and say, okay, based on this program here right now, what can we infer? What can we say about the types, right? And from all this work, lift enough type information so we can find obvious typing, not obvious, I don't think that's the correct word. So we can find certain type violations. So at the moment in the Elixir type system, if we report a warning, it's because it's, it's because we are sure a bug is going to happen. It's not because, oh, it may happen, right? Because the type system cannot capture all the runtime properties of a program,
Right.
right?
It's the
So if we
halting
are
problem,
not
right?
sure, yeah. So if we are not sure, we are like, okay, we're not going to emit a warning. But if we are sure it can emit a warning, then that's what we do. So that's kind of what we have been doing. And with Elixir 1.20, we finally made a type system uh, com complete is not a good word because it has double meaning, but we progress enough in the type system that it understands all the language constructs, it understands all of the data types, and because of that, we have a lot of type information flowing through the program, so we can find those certain bugs that we are 100% sure it's going to happen. We can find that code and give feedback to developers.
Nice. I have many follow-up questions. First of
Yes,
all, what on earth is a gradual typing system?
right. So that's a very good question. So in our case, so we are talking, well, we have Elixir,
Hmm.
right? And our goal is to type and have the type system understand as much of Elixir as it possibly can. But as I told you at the beginning, like there were some times where, when we started, we were we were typing only some few constructs, right? And we were slowly filling everything. For, in that period of time, when we found a construct that we did not understand, we would say that the type is dynamic. So a gradual type system is usually one that has the dynamic type. And it's kind of like there's probably a better, I'm not like an academic type system person. There's probably a better definition because uh, Rust has a dynamic type in any, I assume that Scala has one, C Sharp has one as well, and we wouldn't call them gradual. So there is probably a better definition somewhere. But in our case, we have the dynamic type that tells, look, I don't know what this thing is. I'm going to know the behavior of this thing at runtime. And in here, I just want to do a parenthesis because when I talk about gradual type systems, usually the first thought that comes to most developers is TypeScript.
Hmm.
And but the way that we do gradual typing in Elixir is quite different from TypeScript. So first, like TypeScript is on sound. Sometimes the type system is going to say, "Hey, the type of this thing is a string," but then when you execute the program, a boolean can come out or no undefined. Our type system is sound. So if the type system says, look, it's going to have this potential type at runtime, it's going to be a subset of that potential type that we say. And the other thing is that most gradual type languages, when you have the dynamic type, and maybe that's a difference between the gradual typing in gradual type languages and any in Rust, Scala, and other languages is that the dynamic type is usually like a black hole. Like, if I have a dynamic type and then I use it as a string and then I use it as a number, in a lot of the gradually typed languages, what is going to happen there is that it's going to accept that because dynamics, like anything goes. And that's kind of like an obvious violation. Like even though you know that something is dynamic, if you use it as a string and then immediately as a number, in most programming languages, that's going to fail. But in Elixir, the gradual type does not work like that. We can actually refine the type as you use it throughout the program.
That's
And
at runtime or at
so
compile time?
at compile time,
Hmm.
right? So if you use something as a string, now we know, or imagine, well, so let me give two examples. So if you use something as a string and then you use it as a Boolean, then you're like, oh, okay, like that's obviously incompatible because you start with this dynamic type and then you refine it to, let's say, a dynamic string,
Hmm.
right? And then you use it as a Boolean. There is no subset in common in there, so it's going to fail. But it also works in other ways. So like imagine that you have the dynamic type and then you call it somewhere that expects a string or an array. Okay? So in that case, what our type system is going to do is it's going to say, look, I know that I have a dynamic type, and this dynamic type is going to be a string or an array. Then if you pass to something that expects a Boolean, it's going to be the same thing. Like, look, it's a Boolean. There is nothing in common with a string or an array. But if you pass to something that expects only a string, we are like, okay, this is fine. And that's the way I was saying, like, we only tell you warnings that we are sure it's going to happen. Because if you have something that is dynamically a string or a list, and then you pass to somewhere that is expecting a string, we're like, well, this may work at runtime, right? But if you pass to something that expects only a Boolean, then you're sure it's going to crash. But I think it's worth saying, sorry, I'm speaking too much because there's a lot here. But I think it's worth saying that like that's only the dynamic property. So in so if you have an Elixir program in the future, I'm going to allow you to write type signatures, and you say like this function is expecting a string or an array, then we are going to behave like any other type system where you have to prove that everywhere in that program you can deal with both strings and arrays, right? It's just the dynamic mode that has this property where it's like, okay, I am dynamic, So instead of treating dynamic as a black hole, we are going to refine and try to find more information. So it's a way of making dynamic more useful.
That's fascinating to me. I wanted to ask if or how you wanted to maintain compatibility with current Elixir code because this seems like a dramatic change. And I'm also going to have a follow up question on set theoretic types versus Hindley-Milner, but that's going to come a bit later. So, first, can you tell us about how you want to maintain compatibility with current Elixir code, given the fact that this is such a big change in how Elixir programs are seen by the developers?
Yeah, so I think I have set all the pieces for us to kind of understand how this is all coming out. So I'm going like to rephrase. So like I talked a little bit about the gradual types. I talk about set-theoretic types. So I think now I can paint a good picture of how that is happening, right? So we implement the set-theoretic types. It's a gradual type system, as we said. So what we do is that we treat all Elixir code today as dynamic. Okay, that's what we are doing. So it is as if you went to every function signature in Elixir and said, the input is dynamic. Figure out the output for me, right? So that's effectively what we are doing internally.
And
So
that's
we treat
implied.
everything as
You don't have, there's
yes,
nothing that the programmer needs to write. This is implied by the, mhm,
yes. That's the type system assuming for you behind the scenes,
right.
right? So again, in most other gradually typed languages, if we just said that everything is dynamic, dynamic is a black hole, it would not find any bugs. But in our case, we can refine dynamic and find the obvious errors. So that's how we started. So we implemented the type system, and the type system, every new Elixir release is running those checks behind the scenes, is finding obvious bugs for free. The developer they do not have to change anything in their code. And we're going to be like, yep, there's a bug here, there's a bug here, there's a bug here, right? So that's where we are right now. It kind of answer your questions. Like everything is happening behind the scenes. The developer, they do not have to do anything at all. And ideally, and this is very useful because it allows us to optimize the type system without, without requiring changes from the developers. Because imagine we had type signatures and then we figure out like, oh, this abstraction is wrong, or this was not a good way to type this thing. Then if we change the meaning, we could potentially break programs. But now we can do everything behind the scenes, right? So that's the stage that we are at. It's like we're typing everything behind the scenes. We are using the dynamic properties of the type system to find certain bugs, and you don't have to do anything. Hopefully, we just find bugs and your software becomes better. And that's where we are right now. And then the next step is, okay, we are confident that the type system is great. We are confident that the type system can handle most of the huge majority of Elixir constructs, and we can now start changing the language surface. So so instead of us assuming that everything is dynamic, now the developer can say, oh, the first argument is a string, the second argument is a number. And now we are going to type check that as we would type check a Scala program, right? If you don't have dynamic in there, it's going to work as any other type system, right? Where we'll go and we'll make sure that if you have unions, we'll make sure that all the uses of the union are satisfied. So that's the process. And I'm sure that when we get to the part of like, okay, now we have to start writing type signatures, we'll need to have like many conversations as a community to see, I'm sure like some things are going to show up as like, this is clunky to use in a typed way, or maybe we'll figure out like, look, maybe the way we were doing this particular thing was not a good idea in the first place. We have to figure out ways to make the type system happier, but that's the path.
Nice. A very interesting project. I wanted to ask about set theoretic types versus Hindley-Milner, and I wanted to first ask why this particular choice, why set theoretic types, and then I'm gonna ask about how that fits into the community. But first, can you talk about your particular design choice for the type system? Why set-theoretic types?
Right. So for me, the biggest question was again, like I don't have the academic background behind types, besides like what I've learned myself, what I taught myself. Um, but for me, the biggest question is, look, we have an existing programming language, and we need a type system that can support as many constructs as possible. And I did not start with like, look, I want to have a set-theoretic type system. I started with, look, there is a set-theoretic type system, and can we make it conform to the language, right? So after we went through that and we developed new theory and we looked at the Elixir constructs and we're like, okay, this feels it's expressive enough that it can type the huge majority of Elixir constructs, it feels like it's safe to bet on it. So it was not like a choice made up front. It was a potential exploration that we validated with time. And the main and I think there are like two main features that are valuable for us in the set-theoretic type system. One is structural typing, because Elixir not being like a typed-in language, we have like very few nominal constructs. So everything is we are relying on structural typing, something that set-theoretic type systems can do really well. And the other thing that is very common in in Elixir is I believe Java has this as well, and so also most likely Scala, which is a function. If you have a function or a method, you can have like different signatures or heads. So you can have a method can say, look, this method, the same name is going to accept an array as argument, but the same name can also accept a string as argument.
Yeah,
And then,
overloading, right?
yeah, overloading. And I not being not being a native speaker, I always get overloading and overriding mixed up. So like I try to avoid the words because it always trips me up. But yeah, overloading. And I assume in Scala and in Java, you could have different return types, or no, the return types has to be the same.
Overloading means that the signature is different, and overloading is illegal just by changing the return type. So if you have a function with a name and a set of arguments, let's say a string and an integer, you cannot have a function with the same name, the same argument list, and a different return type. That's not possible. Overloading means that you have to change either the types of the arguments, the number of the arguments, and or the return type, but you cannot just differ by the return type.
So in this case, so could I have the same method, integer to integer, and string to a string?
Yes,
Or
that's
okay,
possible. Yeah.
yeah, yeah. So the same in Elixir, and when I explored like, so I said like 2017, 2018, I explored the Hindley-Milner type system with intersections, is because the intersection types is one of the ways they would type overloading in a Hindley-Milner type system. And that was the one that turned out to be slow. Maybe changed because last time I looked at it was 8 years ago. And again, like it also depends on the properties. I'm sure you can do well, I'm not sure, but I believe that you can do overloading and intersection types in a Hindley-Milner type system if you don't have type inference. The thing that was particularly slow for the thing that I was working on at the time and exploring was overloading, so the intersection types with inference as well.
Yeah, this is a tricky thing because Scala has an HM type system, but having union types and stuff was a difficulty, and Scala 3 changed that. So Scala wanted the kind of the best of both worlds and also have most of the compiler speed or the type checking speed of both with some success. So Scala 3 has a very good type system, and it fixed some of the unsoundness of Scala 2, which was due to many generalities that prove to be unsound for certain constructs, like dependent types. So yeah, this is a very difficult endeavor, and I commend you for doing that. How is that landing with the Elixir audience, and how do you balance developer happiness with the new type checking?
Right. So I think so far everybody's pretty happy because it basically means finding bugs for free.
Mm-hmm. Yes, that's a big
Right.
one.
So yeah, that was like the whole design of the type system so far, and it was even intentional because I think, of course, when you are planning to do a big change like that, there's going to you're going to have some pushback, even for like the community showed in general that they were excited for this approach to be explored. But there's always going to be some pushback. But if we are like 3 or 4 or 5 releases, and every release you don't change anything, and you just get a compiler give you a nice error message saying, "Hey, I found some dead code. I found a bug." I think that helps a lot. People gain confidence in the work, and in that's going to be like valuable of their time. But I think like the toughest bridge to cross is still to come. It's still ahead of us for sure, which is when we had like type signatures and so on.
And how's that plan going forward into the future? How do you envision the releases, future changes? What do you think is going to stick?
Yeah, so it's still too early to say. So in my head, like the general idea is we will work on adding type signatures to the language. And as we do that, we are probably going to revisit some practices. And if we find like, look, this is not good, this is awkward, we may like deprecate some functionality that we have in favor of functionality that works better with a type system. But that's kind of I just have like a just general guideline of how I want to approach it, that I want to take it slow, slowly collect feedback as things mature. We introduce new practices, remove old ones, and we go like very step by step, right? It's not like a boom, everything is done, but continue with this trend of being, I say joking, like it's a gradual type system because it's a gradual type system that is being gradually introduced.
I
So
think that's
yeah.
smart. So I wanted to ask about developer happiness because you've certainly prioritized this, and that is certainly a driver to adoption. And I wanted to ask about design decisions in Elixir that specifically prioritize developer happiness that you saw pay off. Does anything like that come to mind?
Yes. So some of those there were like lessons that came before Elixir. So I think for example like the focus on tooling, and I think the Go programming language was a very good example where they released the language and it came with a bunch of tooling out of the box, like the formatting. Before, like many programming languages, they were like, look, here is the programming language, and now if you want to deal with packages, if you want to deal with dependencies, like you had like, so every project uses like one tool for formatter, one for managing their tasks, one which is like the package manager, right? And Go came with this unified approach, and that was before Elixir. So I think Go was like kind of, I think after Go, I think it became kind of obvious that now every new programming language they need to solve the tooling question out of the box, and Elixir did that, right? So when you install Elixir, there is already the build tool, the compiler, the test framework, everything like everything is unified in a single place. And that was not my lesson to learn, like not my lesson to teach. I did learn it, but I think it was important. But I think the one thing that Elixir does really well, and it's related to developer happiness, is our focus on documentation. So since the beginning, I said, look, documentation has to be first class. So one of the things like, and it's even like from small things like in Elixir, documentation and code comments, those are different things
Hmm.
because
Yes, for
they
sure.
use different syntax, right? Because they ultimately have like different audiences, and you often working in projects where even like open source projects where they can't like there is no distinction. Those things get messed, they get messed up, and I think having that distinction is also like really useful for you to get the message across. Like a lot of people say, look, code comments are not important, right? Like if you need a code comment to explain some piece of code, it means that that code should be clear. But when you separate those things, like documentation is non-negotiable, right? So we treat documentation as first class. I like to say that documentation should be easy to write, easy to read, and easy to access. So we have like first class APIs for getting documentation. And in Elixir, we have the package manager, which is called Hacks. And it also, because of that, we have all the tooling around documentation, and we host all the docs of all the packages in a single website. So there is hexdocs.pm. All the packages are there, including Elixir itself, all the versions. So if it's like, look, if there is one place you need to go to learn everything you need to know about Elixir, it's everything is in there. And we have like being like constantly adding features to that because we have like this unified documentation. So one of the features that we added last year was a search. So now you can search across sorry you can search across like all the packages that we have, which in this case, like, sure, you could use Google, but something that you can do is that you can, in your project, you can say open a search for my project, and then we get all the packages in your project, we get all the dependencies, and now you have like a search engine that is only for the things, for the dependencies that you're using in your project, which is useful, for developers to find anything they need, but it's also very useful for like coding agents, right? So we expose that as tool for coding agents as well, because now if they're like, oh, I'm not sure how to use this, right? Like they have a search for that project and everything that matters in the context of that project. So I think we are like very advanced in that part, and it always started because like making it easy for people to come start a project in Elixir and learn Elixir, learn the ecosystem. Because one of the things that I always had in my mind, like, and I assume a lot of it holds true for Scala as well, is that like when you're going to study like Elixir, you are probably going to learn things that in many times you didn't learn or like focus about before. Like so, we're going to talk about immutability. We are going to talk about concurrency. In Elixir in particular, we're going to talk about like fault tolerance. So you have like all those new concepts to learn. So there's going to be a learning curve compared with, a JavaScript developer going to learn Python, right? Versus learning Elixir. And it's very important for us to make like that experience as smooth as possible, right? When somebody hears this conversation, somebody's listening to this podcast and they're like, okay, I want to try Elixir out. They should get started and have like a immediate good experience. And I think tooling, documentation are two very good ways of achieving that.
For sure. And this is something that we are constantly having a conversation about in the Scala community about documentation, clarity of examples, clarity of the ecosystem, uh, search and discoverability. And these are very important pillars for adoption, which is what I wanted to ask about because Elixir, as far as I could tell from things like the Stack Overflow survey and stuff, is quite about the same, just as popular as Scala. And I wanted to ask about how the growth curve looks like for Elixir. And if you're shooting for mainstream, how are you looking into the future of Elixir in terms of adoption?
Yeah, so those are very good questions. And the issue that I run into is that it's very hard to get metrics about adoption, right? Like how well, like direct metrics, right? Because there's not a single way that you can install Elixir. And usually when there is a way, like everything is biased because of like CI data that is downloading packages all the time. And So it's very hard for us to like be like very objective about it in the sense like, look, we're going to do this to increase adoption. And so I think so there are a couple of things that I try to do from that point of view, which is, look, we have to be decentralized as a community and as a language. We need to allow anybody who wants to do something with Elixir to create an event to get people excited about it, to just go and do it. I don't think it should be like a single corporation that decides everything. Um, Everybody should be able to, if you want to, the language tries to be very extensible. So if you want to get Elixir and use it for like machine learning, so today you can get Elixir and compile to run on the GPU. You should be able to do that without changing the language. If you can bring Elixir for distributed systems, web framework. So cultivate like this cultivate multiple domains and multiple areas, not to be like, oh, Elixir is only for web and that's it. So that's kind of how I approach it. It's more about like it's more like a principle approach, right? Look, we should be decentralized. We should rely on the efforts of the community instead of the efforts of individuals, either as companies or persons, and have that take us forward. And there is also something that I think is has been kind of one of it relates to this question, but it has been like one of my like North Stars, guiding stars, which is that like at the beginning when I started the project, I had no idea if it would succeed or not, right? Like creating a programming language is a huge amount of effort. When I worked at a consultancy at the time called Plataformatec, when I convinced like the other founders to let me spend some time on this, I told them, look, I may work on this for like 3, 4 years and we may never get anything back, right? We're going to look back at the end of the day and say, look, this was for nothing. And so I've kind of prepared, like since the beginning, I at the beginning I prepared myself for failure. And I think that was important because I also didn't want to be in a place where I would try to make decisions to make Elixir more popular. I'm not saying that I'm not saying that I don't do that, right? But I think, look, we should make the best decisions for the language and have those help with the language popularity, right? But not do something that I think would violate the principles of the language or the principles of the community just because we think that is going to lead to popularity. Um, so so that has been like my approach with adoption from the point of language design and from the point of community. And then of course, like as an individual, I am involved as a technical advisor at multiple companies, the majority of them doing Elixir. I also have my company Dashbit, and our focus is pretty much help companies adopt Elixir, collect feedback from them, and then invest that directly on open source. So we build new tools or we make the current projects better for everybody. So we can have more companies and we can keep that cycle going. So it's there are many facets here, right? And
Right. And I have so
try
many
to
follow-up questions.
yeah.
This is fascinating for me. Um, uh, I had some more technical questions, but now that you've described how you started Elixir, I have some slightly more personal questions about how you decided to start Elixir as a programming language, which is a huge project. How did you decide to start that, knowing it's going to take multiple years? You said 3, 4 years, and preparing yourself for failure, as you said, knowing that it may not never return anything. How did that come about? Why did you decide to do that? And did you have any sort of fallbacks in place, guardrails, or things that would prevent a, I don't know, complete failure, or let's say throwing away a lot of work, if you had any guardrails against that? How did you decide to start a project expecting failure for such a complex project?
Yeah, so there were several things here. I'm going to try to be brief. So the reason I started was like long story short was because I found the Erlang virtual machine. For me, it was an amazing piece of software back then. When I
Still
looked
is.
at Yes, yeah, that was I was leading there. Like it was an amazing piece of software back then. Because when I started Elixir, everybody was talking about concurrency, and the Erlang virtual machine not only solved concurrency, but it also solved the next problem, which is distribution, using the same abstraction. And they solved, and by the way, they solved that in the 80s, right? So for me, I fell in love with Erlang and the Erlang virtual machine. I was like, look, I want, that's what I want to use. And as I said a few times, I don't have a computer science background. So I started learning more Erlang. And then I was like, well, I need to build something serious. So maybe I should try to build a programming language because I want to learn and understand how they work. And at the beginning, it was that. It was like a learning project. And so that was kind of like one of, and then after I built the prototype, which was really bad, the first prototype, and then I think I spent like 8 months, 9 months without working on Elixir at all because I was like thinking about what I built, the problems I ran into, until at some point I had this like this idea of how I want Elixir to look like, which is much closer to the Elixir that we have today. So a lot of it for me was like learning. I love learning like different things and just getting deep into the weeds and exploring. So that was a very big personal motivation for me. I also like teaching a lot. So even if the project failed, I think I would be able to, like distill good lessons from there, learn things or approach things differently that I could teach to other people. But I was also like very lucky that I was working at a company where I had three other founders and they believed in me, right? When after that 1 year period where I did a prototype and then I was thinking about it, and then I was like, wait, maybe there's something here. Maybe there is an actual programming language that people could use. And I was like, hey, can I work on this? And they said, yes, you can, right? If they had said like, no, if they didn't believe in me, if they said, we don't think this is going to go somewhere, if they didn't take the risk for me, then it likely wouldn't exist.
Interesting. It matters a lot to have good co-founders or a good team that could back you up. And I'm really grateful for them as well that they believed in you, because you all shared the risk. I mean, you took on most of the initial work, but they also shared some risk because you were working at a consultancy company at the time, right?
Yeah.
Right. And a consultancy company needs people spending time on the consultancy object, which is like taking care of your
Yep.
clients, taking care of the projects that you've picked up for them, and it, just having one person out doing a research project is certainly pretty risky for a consultancy company that needs constant projects or constant engagement with clients. So it's very much to be commended for that. I wanted to ask about some. Uh, your Dashbit is still a consultancy company of sorts. Please correct me if I'm wrong. And you're gathering feedback for Elixir. You're putting whatever earnings um, the company makes into, or some, at least part of it, into or downstream into the open source projects. How is that working? And what kind of systems did you set up so that it is sustainable for the Elixir ecosystem in general? Because it's an open source project that has multiple contributors. Obviously, you're doing a lot of work in there. And I'm pretty sure that it has a lot of also time requirements, material requirements. How does that work for you? Did you set up any systems for making that work sustainably?
Right. So I think there are two parts here, right? So one is like I always seen the community aspect of decentralized, right? So what I do and what the team at Dashbit does is just a small part of the community and what makes everything tick, the whole ecosystem function. So that's part of how it works, and the other part is exactly through Dashbit, right? So in my previous company, the one where we started Elixir, that got acquired in 2020 and got acquired by Nubank, which is actually like a big closure shop, so sibling to Scala in the
Hmm.
JVM community. And at the time, we were maybe 70, 80 people at the company. So it's not a large company, but it's 80 people, right? And
Which
we
is
were
big for a
already
consultancy
doing
company, by the way. I mean, tech company like product
yes.
companies can grow like thousands of people, but for a consultancy company, 80 people is quite big.
Yeah, so and I already was doing something that resembles Dashbit inside Plataformatec at the time. And but then when the whole thing happened, right, I was like, look, I did the big consultancy before. I don't want to do that again. Because it's like, as you said, like we have people at the company, they always need to be in projects, so you need like that sales pipeline always running, right? So the new projects arrive and then you can have the team, like there is a lot to make that whole thing work. um, and I was like, look, what I want to do is that I want to work with it's not about volume in this case, it's about quality and quality for everybody. So I want to work with a limited amount of clients, right? So we can help them, we can get their feedback and use that to improve the ecosystem, right? So for me, it was very important that a good chunk of our time, it's actually on open source development, working with them and fitting that back in. And it was designed to be like a small company, right? So, like the team of consultants, today we are four, and we have recently started exploring some products. So we grew the company a little bit. So we have two people working on the product side of things. And we have Guillaume, the PhD student about the type system. He's also working with us. So it's a seven people, and I'm not growing way beyond that. So, it's meant to be like we are meant to do like this small contribution as part of the whole community, and it's something meant to be small but run really, really well.
How do you maintain focus on the open source ecosystem, given that your team is very small and the ecosystem is very big? What kind of systems did you set in place for the open source project, including the Elixir language, to be sustainable, given that they all require a significant amount of time and effort?
Yeah, so my view, so when I started Elixir, I kind of knew that Elixir would be immediately good for web development because I was coming from the Ruby on Rails community. So the people I would convince first, that's where they would most come from because that was my audience. And at the beginning, like if you asked at an Elixir event, like, oh, who is coming from Ruby? Like you would have like the majority of hands. Today, that's not the case anymore. It's quite diverse. So I knew it was going to be good for web, but I also knew like, look, coming from Erlang, Elixir should be good for distributed systems as well, right? And there are probably like uh, a bunch of other like use cases that would be possible. So I always found myself like my two main responsibilities is to support people who come up with new domains where Elixir can be used at. We have like Nerves, which is for building embedded software. We have Membrane for building data and video processing pipelines. So there are more. Um, so I always thought like, look, my responsibility is to support them, and if I find a new opportunity, a new domain that we should get into, like, or invest into that, or work with the people who want to make that possible, right? So the most recent example was when we started working on numerical Elixir. So Elixir runs on the GPU, and today, like, like there is a new, like, you can get the Quen models, which is a large language model that is open source. You can implement them in Elixir and have it running on your GPU. So all those things are possible today, and that's an effort that we started with people in the community. So that's how I tend like to like think about a lot of our efforts. It's kind of like uh, I'm not sure if there's a good word, but it's kind of like sometimes we are going exploring something and getting people excited about it, and then after some time I'm like I am no longer involved because we kind of like we built a tent, and now people came in and people more knowledgeable than I am, right? So it's very funny because like when you start this numerical Elixir, right? Like again, machine learning is not my background either, like, but I work with them, we build the proper foundation, and then immediately people who are way more knowledgeable about it than me, like they started joining the project. And we also had like people more knowledgeable than me at the beginning, but at some point I was like clearly uh overnumbered, right? Like the people that know quite more about what they're doing than me, they were like, okay, we understand the foundation is good, we can take it forward, and I don't have to be involved anymore, right? Which in a way, like it's quite similar to the type system, right? Like of course I am involved in that process, right? But for example, like there are papers that I am an author of, and there are sections in the paper that I don't understand because it has all the mathematical proofs and background, right? So, if I said anything wrong about types, which I'm sure I did, like it would be, I'm sorry, bringing like Giuseppe Castagna or Guillaume to the podcast. I'm sure they will be able to do way better explorations, but I think those are good examples of how I see my role, right? Is in like helping people channel like like their interests and put into the community and make everything better.
That's admirable. So you're basically an enabler for other people to channel their energies into
Thank you.
something
Yeah,
right.
that's a very good word. Thank you.
Right. Yeah. Uh, and I wanted to ask a follow up question, which is at which point do you stop? But you kind of answered that, which is when you get a decent pool of talent and effort, and also availability to pour into that project. At which point you can say, okay, this project is sustainable enough. And
Yeah,
I
and just that can be one thing. It can also be that sometimes. So one of the efforts that we did, called Gen Stage, that actually got a lot of inspiration, both from the Scala community because of Akka streams back
right.
then, and RX effort. So we have like this thing called like Gen Stage in Elixir, that it took like I think more than 1 year for us to figure out the abstractions. But once we figured it out, it was implemented and it's done. So there are things that like they get done and it's done, right? You don't have to do much anymore. But there are also sometimes where you build a project and then no one comes, right? You try this idea and it's like, oh, it didn't go anywhere. And I think it's also important from time to time for her to say like, okay, like like we try, the foundation is there, like maybe we are going to leave the tent, but if somebody comes and they want to take the spider webs out and say like, oh, this is actually a good place to be, we did the exploration and the initial work. So yeah, not always it succeeds, and there are those other possible exits. Sorry, please continue.
Yeah, I mean, I wanted to ask about uh, how do you maintain an open source project alive um, after the main maintainer leaves or switches focus and stuff? Because you've worked on many open source projects, including some very popular Ruby gems. How, if you have any rules or any systems in place for that open source thing to stay alive after you leave, uh, do you consider them done? Do you bring in some other contributor to, I don't know, maintain and bug fix and security vulnerabilities and whatnot? How do you think about that? And then I have a follow
Yeah,
up
so
question.
yeah, so some are done. Some, you maintain it and then so there are a couple of things. Like, so some get done. Some, I think like the initial onboarding experience is very important. So something that I tend to do very well is that like when someone submits a pull request and it's a really good pull request, sometimes somebody open up an issue or open up a feature request which is related to that area. And then I'm like, hey, there's this opportunity. I pinged the person. Would you be interested by any chance? So like there's this you can cultivate developers at the very beginning of the project when there is that huge amount of excitement, right? And that early multiplication of effort is very important, right? Because then you bring that person hopefully is bringing somebody else. Um, so so there is a lot of that, but I'm also like very comfortable with, everything is open source. If there is no interest, if nobody's stepping up to being a maintainer for a given project, I'm just very comfortable with saying, okay, it's there is no interest. If somebody wants to step up, that's fine, but I wouldn't necessarily like go like worry too much about it, right? It's kind of like a market speaks for itself kind of thing. And the big project, that's just not going to happen, right? There's just too much interest for people to get involved and to participate. So unless like as long as you keep that participation channel open, you are always going to have like fresh people joining.
Okay, I have two questions for that. It seems like you are doing a million things. You have many open source projects that you're involved in to some degree. Some hand over to other people. You're having a consultancy company. You're organizing conferences. You're writing documentations. You're writing blog posts and stuff to clarify various aspects of things that only you can clarify because you're in the middle of it. Um, I wanted to ask how your day looks like, but rather than asking that, I wanted to ask about how 3 months look like because I'm pretty sure that you're focused on one thing at a time, but that focus probably switches every couple of weeks, maybe. I don't know. I wanted to ask about that. How does a quarter look like for you?
Ooh, the quarter, that's a new question. I'm not sure. I'm not sure if I have an answer. I think in general, like we kind of have like the general notion of how it works. So I think you use a very good word, which is I am enabling other people, right? So sometimes there's this appearance that I'm very productive, but it's because uh, often I am writing something that it happened after conversations and working with three, four, five different people, and I am just kind of like writing the meeting notes in a way. Um, so I think part of it is that, and I think thinking about like I think my day is kind of a usual day. I would say that I do spend too much time to I think nobody's surprised that I do spend too much time at the computer. Not saying this as something I'm necessarily proud of, just recognizing that that's the case.
You're a programmer.
Uh,
We all resonate. Everybody listening or watching this can resonate.
Yeah, so on the day to day, there's definitely a lot of times in front of the computer and working, but over 3 months, I think the the thing that I try to do, and it's not every 3 months, it's kind of like every day or every other day is the planning, right? That's very important, right? It's you know, what do I know that I want to do for the next 3 months to the next 6 months? Where do I think we're going to be in a year? And sometimes you don't know the answer, right? So you are asking me questions about the type system. So I can tell you pretty comfortably where we're going to be in 3 months, in 6 months, right? But if you ask in a year and a half, I have a general sense, right? But being able to assess that, right? It's is and think about that. It's very important for planning and especially for to be an enabler, right? Like to keep everybody in sync of that's where we're going. So you're not like changing course every 3 months, right? Because that's just going to slow everybody down, right? So if you can adjust course as you go, that's clearly preferable.
One final question on this chapter, and we're probably going to move to some other things that I'm very interested about. Um, on open source projects, there are many packages, tooling, even languages or frameworks that are being used a lot. They're very popular. They're used by companies, but they're not giving back. How do you handle that?
I honestly, I think that uh, the question of how I handle it, that particular, I think there's a lot of angles we can go here, but the particular question of how I handle it is what it is, right? So to me, it's like, look, it's open source, and the open source comes with a very clear license that, it is what it is. There are no warranties. You take the software as is. So that's what I put out there. And that so it's like, well, nobody should like not because I put Elixir out there that people should expect support, that people should expect my attention or my involvement in anything. And I think like for the same angle, right? It I'm not expecting something back from anything at all, right? For me, it's a very simple system of like I'm giving this, I'm expecting nothing, and you can use it, and I'm expecting nothing, but you're also not expecting anything from me. That's how I generally try. So again, like going with the very handle approach, like psychologically, that's how I make like my peace of mind. It does not have to necessarily be the best way about it. I think more involvement of everybody would be is the right way to go about it, right? But how I handle it, how I don't lose sleep about, somebody making billions of Elixir and not giving back is because that's the contract that I signed.
I'm also asking this in the context of many examples of open source projects that, for some reason or another, either lose maintainers because they involve a lot of effort and they're not getting paid, or they kind of switch licenses to something that makes money, like a business license of sorts, and that enrages the open source community because for some reason they expect quality software for free, but the companies themselves that are using said software are not giving back. So there's a tension between the open source community and the business community expecting certain software that they use to work and causing friction whenever something goes unmaintained and they have to switch stacks or they have to rewrite parts of their software and stuff. It's one of the reasons why I asked this particular question. And I wanted to maybe to touch on that briefly. If
Yeah.
you've seen such examples in the Elixir community and how the community handled that.
Yeah, so I'm not So, okay, so I'll speak about that less from the point of view of examples in the community, because I think in that regards, the Elixir community is pretty much like any other community. So there are people who are doing fantastic work and they are well supported. There are people who are doing fantastic work and they are not supported. There are people who maybe change the license. There are people who, but speaking about the problem in general, right? Like I do think that. So if I could go back in time and like have a conversation with myself about open source, like the 15 years ago, maybe let's say 15 years ago, the vision I had about open source was a way more. how do you say, glorified vision. Like it was like I idealized, like I had this like ideal version of open source of like, everybody does good. It was not the neutral version that I was giving you, right? I was like, oh, that's what I put. I expect nothing, right? It was way more like, look, it's open source. That's how we kind of build the world together. And I don't have that vision anymore. And as I told you, like I was lucky to have somebody, like to have a team of founders that support me, right? And not everybody's as lucky. And for me, it's in certain ways, it is like upsetting to see like people who are producing software that's clearly bringing value to a lot of people, right? And they cannot just be producing that software. They have now to figure out, look, I have to I have to create a company. Now I have to create a consultancy. I have to become how to be a seller, right? How to figure out clients, figure out contracts, like figure out all the aspect of running a business, right? Which sure, like a lot of people in the world, they have to do that. Like if you're going to open a market on the corner, you have to figure out all those things as well, right? But and sometimes people they get burned out, not necessarily because of open source, but because of all that other work that they have to do just so they can work in the program. And it is upsetting that we don't have a good answer for that, right? Uh and yeah, so it's like this. It is a tricky problem, right? And it's even hard to have discussions about this, right? Because if I bring this up, it's like some people be like, "Oh, boo-hoo, he has to open a company," right? But it's also about, if you have like like any company, right? Like if you have a really good engineer, you're not going to put him on the sales team or her on the sales team. You're not going to put them on the sales team, right? But that's kind of what we are asking from open source developers. In many cases, we are, as a community, sometimes not like getting the best of the people involved because we don't support them. So that's kind of like my general angle, but like my personal peace of mind with all of this, how I handle it. I found my own peace of mind in it. Yeah.
I wanted to ask about AI, uh, and there are a couple of directions that I would like to take this. Uh, Maybe we can touch upon Elixir's mini stack on AI, and then ask about general AI and how you see the Elixir community going forward. And I wanted to start with NX, which is a this pretty ambitious small ecosystem for number crunching with the goal of enabling general ML. Why should people choose this stack over Python?
Right. So, and Next started, oh, I don't remember the year anymore. I think it was 2021. So here's the thing is my my background is engineering, like automation and control engineering, mechatronics engineering. But when I was graduating, I I was already a programmer. Like I was already when I was writing my thesis, I was already on like the Rails core team. And because like mechatronics is kind of like this everything goes kind of thing, right? Like it's mechanics, it's electronics, it's computers, it's like computer uh, software engineering, right? It's like all those things. Like it's really a depth. You learn everything, but nothing really uh, in depth. I was already interested, and I was like, okay, I wanna. I went to the software engineering department and like, hey, can I do my thesis here? And I did my thesis in machine learning. Okay, so this is in 2009, 2010. And at the time, like neural networks, they were not the thing that they are today, right? It was, I think, just before, I think like the first real advancements in neural networks came in like 2011, 2012. So I always had this interest. I always found like that particular part interested, but I never knew how to bring this stuff into Elixir. And we can, if we want, we can talk about it, how it works later, right? But I think in 2000, again, I'm not going to remember the dates, about 5, 6 years ago, Sean Moriarty, he wrote a book for genetic algorithms in Elixir. And I say joking like it's the like one of the books that I didn't read, but it changed my life because it was basically the signal like, look, there is somebody who is interested in like machine learning and Elixir, and I should just get in touch and start talking to them. So I reached out, and then we find some other developers, and we started building what is an Next today. So, so the funny thing is that it was in a way like by luck. I had the interest. I never knew how to move forward with it. And then Sean, not really like we did not know before he released the book. We started talking. Jacka was another early member that helped us very early on in the project, and we started building it. But it was like just before AI like really took off, right?
Good
It was
timing.
still yeah, it was like before. And the funny thing is that it was like coincidence, but people are like, oh, like you had the vision. It's like, nope, like zero vision. It was like just interest and coincidence. So it was like before Stable Diffusion, potentially even before GPT-2, we started building all those things, right? There was clear interest. Things were growing on the Python side. So we started building all this infrastructure. But going back then, like we knew that things were growing, but I didn't know it would get to the side that things are today and that the models are so big, right? So when we started the whole NX, like so the NX project, being able to get Elixir to work with tensors to compile to the GPU, that's really important. That enables a bunch of cases where Elixir was not used before. Um, and NX was a bet in that, look, if the future is going to be that those models, like, so when Stable Diffusion came out, like, you could run it on your machine, right? I think Elixir had a really good shot at being like a viable alternative to Python. Not for everybody, but for many teams, right? So I think that's the niche and the scale of an X. It's like, look, imagine that you're building something with machine learning and you want to like have a user in real time that is connected to a machine that is doing machine learning processing or some sort of federated learning, anything that's trying to mix machine learning with distribution or maybe machine learning on device for embedded software. I think Elixir is a really good option because it mixes the strengths of um, of the language with the strengths of machine learning. But the other hand, like the way that machine learning grew is that we have like these really huge models, right? And and for those really large models, like it doesn't really matter if you're using Python or Elixir because all Python and Elixir. So in Scala, you can do something similar. So when you have like a large language model in Python, so what you use Python for, it's actually just to trace the execution path. So you say, look, I want to do the product of those two matrices, and I have this loop. None of that's like executing the loop in Python. What all those libraries do is that they trace the execution, and I think that's a pattern you can do in
Yeah,
Scala
you
with
call it
Object as
native
well.
code, right? You call C code or C++. plus plus.
Yes and no, right? So yes, so what it's going to do is that when it first executes, so when the Python program runs, it actually doesn't call anything. It doesn't call C code. It just traces all the calls. It builds the graph of the neural network, then it compiles, and then it compiles that graph, it does a call, right? So like, so it's not like, look, you have this neural network and it does like uh millions of native calls. It's like, look, it just compile everything and the like three native calls at the end. One to compile the network and another one to run it, which is how we implement it in Elixir. But that basically means that it doesn't really matter much in terms of like performance, which language you use, because what every all those languages are doing is that they are just building this initial
Yeah, you
graph,
build the DAG and then
giving
you
you
call it, and then you call the invocation after you made the DAG, right?
yeah, and you know and then even like so people are like, oh, but maybe Elixir distribution can be used for like coordinating multiple GPUs and things like that. It's like not even that. Like the GPUs, they talk directly to the GPUs. Like you connect the memory from one GPU to the other GPU. Like there is. your like Elixir is not involved, Python is not involved, like not even like your usual operating system memory is involved. It's just like GPU direct computation. Um, so yeah, so I think that's kind of like the general thought and my agreement on this. I think like there is value in NX to solve certain problems, but if you're like, look, we are like training a large model that is going to require a huge amount of GPUs, and I think like the incentives to migrate that to Elixir, they're not going to be high because at the end, all Elixir in Python is doing is assembling, and everything else is running natively.
Right. Uh, I wanted to take on the other direction of the AI related questions, which is how does Elixir position itself in this age of AI and the AI agents in particular? And does it really matter? I mean, I want to calibrate that question. I've seen discussions in programming communities and in the Scala community as well, because we are having this conversation about AI agents for Scala code bases. And a theme that pops up is, do programming languages matter anymore? Can you just write everything in Python, let the agent do the work, tell Claude, fix this, and just write TypeScript in Python, and then you're done? Do you have that conversation within the community? Does Elixir want to let's say compete with the Pythons and the TypeScripts of programming languages? And how does Elixir want to position itself in general for this AI-enabled developers?
Yeah. So I think there are two angles we can explore here. So one is having the coding agent write Elixir, right, instead of Python and TypeScript. And the other angle is using Elixir to write those agentic systems themselves, right? And it's all related to AI. The same way that NX is also related to AI, but they're all different positions, right? They all have different answers, right? So we talked about NX. So let's talk about Elixir, like having the coding agents write Elixir. So I think the truth, or at least my canon, is that nobody really knows the answer, like if it matters or not. So there was a study from Tencent that like put Elixir as one of the best programming languages in terms of the agent generating like working code um, and solving problems quickly. And they are like, and I think we need more studies to be to to come with a conclusion like, well, is Elixir really doing better than the other languages because it came in first place in this study? Or if not, and why that is happening? Like we really don't know, we really don't understand. So and I think you can take like a bunch of different angles in here, and because nobody really knows, in my opinion, they're all valid. So one could be, yeah, let's just do everything in Python TypeScript, right? Sure, that makes sense. The other one is, well, if the agent can write any programming language because it can write Python, but it can also write Elixir, right? Why not have it write a programming language that it supports concurrency, supports fault tolerance, supports like you have the huge majority of um, mobile internet, LTE, 5G, whatever, in Europe, right? Going through airline systems, right? So why not use a language and a platform, right, that is known to be fault tolerant, to do concurrency, right? To be scalable. Because yeah, for the agent, really doesn't matter, right? It could be any. So and that's a also completely valid point of view. My take at the moment is that a lot of people think I don't have like I don't have indicator that I right now, based on everything that I see, that we are being replaced. I think like there are solid problems that we'll have to solve. Like we have to figure out like how we are going to onboard junior engineers at a moment where you can have AI that can produce work that is similar to them or sometimes better, right? Like that's something that we'll have to learn how to deal with as an industry at some point, right? But I like from my and I try like I'm actually open to coding agents in general. I think it's exciting. I think it can be a possibility to bring more people to build software. A lot of challenges there, which makes it also exciting. But I don't think we are being replaced, right? So from my point of view, like if we are not being replaced, we are clearly going to be the bottleneck, right? Like the agent can understand code faster than us. The agent can write code faster than us. So if we are being the bottleneck, we have to choose the best programming language for humans or for our team, which for me, it's pretty much how language adoption has gone historically, right? It's not really programming language, they do not get adopted on technical merits, right? It gets adopted based on the people, on the experience, on the community, on marketing. And I don't think that will fundamentally change the equation. I think, of course, it's going, because the agents they're going to default to TypeScript and Python, it's definitely going to increase like the amount of TypeScript and Python code written and of the top languages. But that's already not a close race anyway, in my opinion, right? Like when you look, so when you're talking about metrics, there were some metrics that were used to follow back then. Some of them was like Stack Overflow, which not relevant today, right? But it's like the order of issues that you get from like the top five languages, right? It's a huge difference. Um, so that's kind of my answer for that thing about the coding agent. That uh, I think we should continue. I think languages still be chosen when somebody's making an explicit choice that's going to be guided by users. Of course, the agents can help. You can have conversation with the agents to help decide those things, but I still think the principles are the same. So my approach with like to a lot of these is continue making Elixir great for humans, which turns out that when you make a programming language good for humans, you usually make it good for agents as well, right? Like the things that I was telling you about good tooling, it's also fantastic for agents. Good documentation, excellent for agents. Like I was talking about how documentation is on a single place. It means that if you're training a model, you need to point to one domain and you learn everything you need to learn about Elixir and the whole ecosystem, right? So that's kind of my angle. It's like I'm still going to like I'm still putting like the human first when I think about those things.
Excellent. Excellent choices. I wanted to touch on the marketing things because you mentioned some pillars for making a language adopted, and you said that it's not technical merit per se. How does marketing fit in? How do you think about that? And how does marketing for Elixir look like right now? And how do you envision it looking like for the next phase of Elixir?
Yeah, so from my point of view, it's like it's very similar to how I approach everything, right? It needs to be a community effort, and like I am good technically. I think I'm very good to sell to developers, so I can speak in the language of developers, and I can talk about trade-offs and make developers very excited about the things that I'm interested. So I can do the technical marketing, the developer marketing, but then the rest, like how do you convince CTOs? How do you convince other sorts of leaderships? I don't think that's my strong suit, and that's where we have to rely, on everybody in the community bringing their strengths and make that happen. So for me, it's the same. It's like it's the same answer, right? It's a decentralized approach, and hopefully, we are giving everybody the opportunity to chip in with their takes.
Um, I wanted to ask about this speaking to developers part. You've spoken at conferences. You wrote many technical blog posts. Obviously, you uh, you're a consultant yourself, you know how to work with a technical audience. What are some principles that you've applied while marketing Elixir to a technical audience? For example, I mean, another brutal way of asking the question is, the like the Wolf of Wall Street meme, like sell me this pen. How would you sell Elixir to, for
Uh,
example, this audience? Right. This is a more brutal way of stating the question, but I think
yeah.
you understand my point.
Yeah. So the way that I approach it, which is not how is not how a marketing person would probably would do it. Which is I try to approach it through reason, right? So I don't say that Elixir is the best language, right? Because what is first, there is no such thing as best language, but what is best? Best for what and under which circumstances, right? So my approach is, and I also have like this saying, like a lot of us, like when we are having those discussions, we try like to bring opinions into it, which for me, for technical discussions, it's like absolutely useless, right? I say like, look, if all we have is opinions, I prefer mine, right? Like done, end of the conversation, right? Like so the way that I approach it is that so like for example, when I was designing Elixir and I was making choices, the huge majority of the choices they were conscient choices. Like I was like, look, I'm doing this because of this. I thought about the trade-offs. Those are the benefits that we're going to gain. Those are the downsides. So when I'm talking to a technical community and I'm trying to say, so like when we're talking about the type system, I can explain my process, right? And I can say, look, that's why we made these decisions. That's why those decisions were important, right? So if you agree with those decisions, if you think those are valuable trade-offs, right? You're going to say, yes, I agree with that. That's worth checking out, right? Which leads to like some sort of like we have the thing that we said in the Elixir community, and maybe that's one of the things that AI can help change Elixir for the positive, which is that like I think us as a community, we are really good, or no, let's say not us as a community. I'm going to say myself. I am really good selling to developers, especially senior developers, right? Because when I come to you and I say, look, it's a language that makes concurrency simple, right? Unless you spend a day or a night trying to debug a race condition because of a silly mutability concern, you're not going to value that, right? When I talk about how Elixir has supervisors to make sure that your software can deal with failures, right? Unless you had a team that had to be on pager duty the whole night because something was going wrong in production, you're not going to see the value in that, right? So when I come and I tell like those properties of Elixir, like like oh, immutability and how it makes the code base easier to understand, unless you worked on a massive code base, you're not going to see the value on that. So when I explain from like this reasoning point of view, and then a lot of it is like, oh yes, I understand. Uh, I see the trade-off and I understand why he made that trade-off and I agree with him. Sometimes it's something that it's easier to sell if the person has lived that. But that's how I think about it, right? Like for me, like selling and marketing is like teaching. I'm just teaching like why I think those are good ideas, those are good practices and why you should care about it.
What teaching principles did you acquire along the way? Because you also strike me as a good teacher, especially seeing your conference talks and the way that you explain complex things in just a short amount of time, uh, in a way that I'm pretty sure that this audience will get the grasp of very quickly. What teaching principles did you acquire along the way? Was that a conscious growth um, that you've intentionally focused on for yourself, or did that happen along the way? Did your entrepreneurial journey with the consultancy companies talking to clients enable you to do that? How did that come about?
No, it was not. No, it was not conscious at all. I mean, I do have like, there's this teaching aspect of me. It's something that I had since I was like very young. So like when I was not in high school. I don't know the words in English, but it was like, let's say sixth, seventh grade. Like the teachers, they would put me to give the, so when somebody was not doing well, and then they had to learn to prepare like for the additional exam to see if they could pass, like the teachers would put me to be like, hey, would you like to go and teach them and explain? Um, since I was very young, and I loved that there was a period of time that I was, when you had like young adults that they could not be at school for different reasons, but later on they wanted to finish, right? Then they have those, they would take classes to do the exam so they could get the degree. I taught that for some time. My brother was a chemistry teacher, very popular in Brazil because he was very early on the ad tech scenario for a good period of time. So some of it's runs in the family, but it was mostly that. And I it was not conscious, I would say. I did not. It makes me think that maybe I should do it. Um, but yeah, and but for me the thing is that, but for me, like the teaching and the learning, they go side by side, because I love learning. Like learning, discovering new things, like makes me feel good, right? Like it makes me excited, like thinking about the possibilities. So for me, teaching is about getting other people excited about the other possibilities and other scenarios in the same way that I get excited when I learn them. So that's kind of how it flows in my brain. Like it's like, it's like almost like in a meme way, like, oh, I learned this thing. It's so cool that I have to tell somebody, right? That's a lot of like the teaching for me. So a lot of discussions, even for me, is not really about like who is right or who is wrong. I actually don't care about that. It's just like about like collectively, what can we learn from this? What are the trade-offs? And maybe at the end, you're going to make a different decision than mine because you see the trade-offs differently. But if we can all agree on the trade-offs, I like not on how you place them, but those are the trade-offs and those are the things worth discussing. Then I'm happy.
I can very clearly resonate because I'm also not a trained teacher by any chance. But in the process of learning, you obtain enough clarity and enough excitement to be able to, or to want to show to other people. And exposing that clarity then feeds back into the learning process, because while explaining something clearly to somebody, then ideas click differently in your head, which then solidifies your own learning, which then makes it easier for you to then put things into plain words, especially when it comes to complex topics like, I don't know, concurrency, distribution, fault tolerance, and technical things that are heavy. When you get into enough learning loops like that, you gain enough clarity that you kind of become a teacher natively without having training or specific focus about that. So I can very clearly resonate. I wanted to ask about the. I mean, we could segue from teaching. How would you describe the Beam virtual machine to a JVM developer like the ones that are listening or watching this conversation? What are some key principles that people could take away for JVM developers like Scala and Java stuff to learn about the Beam?
Yeah, so I like usually my conference talks, since we brought it up, the way that I like to talk about the Beam is like how it came to be. Because so it was created at Ericsson, which is a telecommunication company. And one of the things that they had to build is like telephone switches, right? So, and if you think about a telephone switch, right, like you're going to deploy it somewhere, and it has to, and again, like going back to the 80s, right? It has to deal with hundreds of thousands, millions of connections at the same time, right? So it already comes with the idea of concurrency, right? But also that thing is like it's basic infrastructure, right? That thing cannot go down. And it's not like at the time we had like Kubernetes or whatever, where one machine went down, like another, you could start another machine. Like the thing had to be robust, resilient, right? So they thought about all the ways about, well, how can we write fault tolerant software, right? And one of the amazing things from that is that like they did not start with like, look, we want a functional programming language. That's not what they started with. They were like, look, we need a programming language that is fault tolerant. And then they realized that the mutable state would get in the way of that because if you have a component that gets corrupted and you have global mutable state, right? When that component gets corrupted, what can you assert now about the global mutable state, right? And it's tricky to assert anything depending on where that component got corrupted. So they wanted to avoid that, which brought immutability, and which lends to all the similarities to functional programming with pattern matching uh, as well. So, and then they did other things like, well, a telephone system is obviously a distributed system, so they had to solve those things, those problems as well. And I have this joke that I say, like, the other thing that they had to do is that, and that's one thing when they announced their link to the world, like when it became open source, that's that's the thing that they showed, which is also like, how do you do deployments? You cannot do like the usual, like blue and green deployments where you just bring everything down and you will start a new one because there's always somebody on the phone. You cannot just drop those connections, right? So they're like, well, we have to be able to upgrade the code live in production right, without dropping a call. And that's what they show in the video. So for me, it's just fascinating because they started with all those problems that they want to solve, right? They did not start with like, look, I want a functional programming language or I wanted this. Like they did not like today we would say that Erlang implements the actor system, but they did not know the actor system back then, right? It's just that based on all those decisions on how you can write software that is concurrent, distributed, and fault tolerant, they landed on something that later turned out to be very similar to the actor system. And I think, and it's really like the only platform that was like literally designed with all those things in mind, and it's being used at massive scale. And it turns out that a lot of the things that we do today, it's pretty much that, right? Like you're building a web app, right? Now uh, you have all the real-time components. It's collaborative. You have people from their phone. You have people um, from their computer for some reason off maybe even your fridge is going to be connected to your app, so you have all those connections that you have to handle. You have your cluster that are running internally, information coming and going, and it's a platform that if you're writing anything that is collaborative, it's real time, it was literally designed for that. So everything that you need is like it's part of the language. Like you need to coordinate work across nodes. You need to do something real time, send a message. You don't need to bring RabbitMQ. You don't need to bring Amazon. Like all of this communication, everything part of the language, part of the runtime, built in, considered into everything, right? And especially like and it's funny like because since I started doing Elixir and Erlang, like we went through like some reasonable changes like in software. So like 2007, this was a little bit before I joined Erlang, like the iPhone came out, right? And but like before that, most of the websites is like it was like pull, right? It's like, oh, you wanted to see something change on the page, you had to refresh the page, right? Like, and then with the phones, we started change the patterns, or we started pushing information. And again, Erlang is excellent for that, right? And then we have IoT, which are more devices connected over different protocols. Boom, Erlang is excellent for that. And now we are talking about agents, right? And building agentic systems. And again, it's like, what is an agentic system? You have a cluster of machines that have a bunch of humans connected to it. This cluster of machine is connected to a bunch of different agents. You have information coming and going all the time. So how are you going to build that? Erlang Elixir is like out of the box everything that you need, right? Like you can even upgrade the code that is talking to the agent without doing any sort of red green deployment, or blue and green. Sorry, I'm confusing the with the red green from TDD. With any blue and green deployment, right? You just can upgrade the code live. So it's kind of amazing for me, like all those decisions made in the 80s, like for this like 15 years that I have been doing Erlang and Elixir, like you see like new generations and things changing in how you we build software. And I look at it as like, yep, turns out it's still great for that. Nothing changed. Still the designs from like 3 decades, 4 decades ago, they're still good.
Yeah, there are definitely a few, a handful of technologies built, I mean, decades ago that are still very, very relevant today based out of a few core principles. So, what I'm getting here as a JVM developer, I've never written code for the Beam, and I'm very curious. So, the JVM has a couple of core principles to it. One is the ability to write one's deploy everywhere, and two, the garbage collection. So, these are two of the fundamental features why somebody should adopt a JVM language like Java or Scala or Clojure for that matter. So what I'm getting from you from the Beam is hot swapping, deployments, concurrency, and distribution. Anything else that is fundamental to how the Beam
Fault
works?
tolerance.
Fault tolerance, yes. How does
Yeah.
fault tolerance work? Because I've done some Akka back in the day. Akka, the actor framework for the
Yeah,
JVM,
yeah.
it was written in Scala, and it was very much inspired by Erlang and the actor system that they came up with. How does that? Can you explain to people how fault tolerance works on the Beam versus the typical error handling that we used to do in traditional languages? And with the abstractions that come bundled with that, for example, Scala has a couple that has try, it has either, it has IO monads, it has various forms of error handling. Akka goes in a different direction with fault tolerance and supervision. And how does Beam differ from that?
I believe it's very similar in so again I have to be very I like what I know from Akka is because like back in 2013, 2014, around this time, it was very common for to have events where the Erlang people and the Scala people they would hang out together, right? So I don't know much, but I think in general, the principles of like supervision trees and thinking about, look, software can fail. So you need to be able to write rules to restart the software when something goes wrong. I think those things they are very similar, right? The only I think at the time, and this may have changed, I think the main two, not the only, there are probably more, but the main two differences coming from Erlang is that one is that it is a property of the runtime, right? So, like in the Erlang virtual machine, you cannot create programming languages like all the same sorts of programming languages as in Java because like this lack of mutability, this lack of global mutable state, that's part of the runtime, that's part of the VM. So it's really a bottom-up approach instead of something that was added on top, right? Which in some ways it's important, right? Because you need to have one piece of global mutable state to kind of like it like when you're talking about fault tolerance, right? It's like it's the weakest link is it can be enough to bring everything
Yeah, if you
down,
have a tree and you
right?
bring up the guardian, then you're dead.
Yeah. So, so I think that's one, and that we were used to talk at the time. So I'm kind of like collecting things from a decade ago. And the other one, I actually think it was addressed on more recent JVM versions because the the Erlang virtual machine has always been preemptive. So what we would call actors in Erlang, we call them processes, not operating system processes. Those are like lightweight threads of execution. We just call them processes. In Erlang, since the beginning, they were preemptive, and that was so. What it means is that you cannot have a one lightweight thread of execution, one process that just runs forever, right? All they have is that they have the metaphor I like to use that they all get an amount of gas, an amount of fuel. They use it, and when they run out of fuel, they have to stop and give somebody else the opportunity to run. And the reason why they did that, I believe, is because to have predictable latency, because when you have things that can run uncontrolled, right, what is going to happen is that when you have a spike in traffic, for example, you have some requests going really fast, and when you look at like the 90 percentile or the 99, like it's taking a really long of time, they wanted a more predictable system. And so Erlang was always preemptive. So you had this guarantee that, again, like if you have an actor doing something silly or a bug, it cannot hog all the system resources. But I think recent JVM versions they introduced like virtual threads and things more in this direction. I don't know if Akka changed it to use that. That's a separate conversation. I actually, if you know, I would love to hear. But I think at the time those were like the two major differences. It's basically, like I would summarize it like having something built from the ground up versus something that is built on top of another technology.
That's very interesting. Yes, I mean the JVM has virtual threads, and before virtual threads, Akka kind of came up with a sort of lightweight threads because they, on top of the JVM thread pool, Akka had its own scheduler that scheduled actors for execution, and you could treat actors as sort of light threads until recent years. Other systems on Scala came up with other abstractions for light threads. They call them fibers for effect systems, and it was pretty much in line with the same thing, which is that you had a an abstraction on top of the OS thread, which can be scheduled in the millions for for a single computer, and they were allocated on the heap. So you would talk about OS threads into thousands or at most tens of thousands per CPU core, but you would talk about millions of lightweight threads or millions of actors in the Akka sense per gig of heap. So they were basically data structures that were scheduled to run by a scheduler on top. In the meantime, the JVM has introduced virtual threads, which is pretty much the same thing, but at the JVM level. And the JVM offers some abstractions for both preemptive scheduling and also cooperative scheduling. So you can kind of build assumptions in both ways. If you want to do preemption, you could do that. Um, you can create interruptions, but it's kind of heavy, and you kind of have to be careful about it. And you can also do cooperative scheduling, and threads will simply yield when they're done, and there are ways that they can suspend themselves and stuff like that. So it's a bit of both on the JVM world. In the effect systems in
Do,
Scala, it's mostly cooperative, and you can intentionally cancel some effects, or in the sense, you can send poison pill messages to the actors to stop. But it comes with some assumptions and some guarantees, which we can dive into. But that's the general idea.
Before, did Akka migrate to the new virtual threads? Is that a thing in progress? They're not planning to do that.
I mean, Akka can run on many JVMs, and it certainly can run on the latest
I
JVMs
see.
that use virtual threads. Yes.
Okay. Because I know that other ecosystems that that do the schedulers approach, one of the issues that they had is that the libraries had to be aware of that particular scheduler system. So it could be problematic because you're building your project, then you would bring a dependency that maybe just used regular threads or use another scheduler system. So one thing would block the other. Is that something that could happen at the time, and now it can no longer happen if everybody's just using virtual threads, I assume, that come as part of the JVM? Or was that never a concern?
I don't think it was a concern. I mean, you can very easily swap the JVM and the core assumptions still work. I mean, I know for sure that effect systems can swap to virtual threads rather than using their own scheduler, and it just works.
Nice. Nice. Thank you.
Yeah, I mean, abstractions work. Knowing the platform definitely helps. And from what I'm hearing from you, the Beam made some assumptions that basically all the languages that build on top of the Beam have to kind of respect. Am I getting this right?
Yeah.
Right. If a Scala developer had a weekend to learn, say, Elixir, what would they focus on? What's a good use of a weekend time for a Scala developer to get the most out of Elixir?
That's a very good question. I don't think I have a good answer. Like I like to say that I am most likely the worst person to be asked that question. It's a really
Why do
good
you say that?
question. Because the way I learned Elixir is definitely different than everybody else, right? And it was like such a long time ago. It's very hard for me to kind of like to put myself in the position of of somebody. Oh, I have a good answer based
I knew you
yeah,
would.
it's just sometimes yeah, it's just sometimes like it's very hard for me to put in the position of that person and try to see like, oh, what would be exciting for them. I can definitely talk about anything like anything Elixir related for hours, but anyway, going to the answer. So there is this book called Elixir in Action that everybody loves it. So I would say, especially if you are a programmer like us who stay too much in front of the computer, get the book and stay a little bit away from the computer, but hopefully learn some great things. So that would be my recommendation right now. Elixir in Action.
Elixir in Action. Okay, we'll put it in the recommendations and the links for this episode. Jose, it's been a pleasure. I have no idea how 2 hours flew by. It was such a blast for me. Do you have any thoughts or advice or things that you would like to say to my audience before we wrap up this conversation?
Not at the time. I think it was a really good, productive conversation, and hopefully there will be like a useful things to extract from it. So we can leave at that. Yeah.
All right. So I'm gonna leave links to Jose's GitHub and Dashbit and the product that they're building. They're building an AI agent framework that's very interesting, and also the a Livebook, which is kind of like a Jupyter for Elixir, which I found pretty exciting. So I'm gonna leave links to the episode as well. And until next time, folks, thank you so much for listening. Jose, thank you so much for making the time.
Thank you for having me. I had plenty of fun too. Thank you.
Thank you.